Hey guys, welcome to AI with AI. This side Asif Imnat. Today we are going to talk about very exciting topic, that is logistic regression, the math behind logistic regression. It's not about logistic regression, but we will understand what is the logic behind logistic regression and how does this algorithm really works. Let's get started. Before we start understanding the math behind logistic regression, let's do a quick recap on linear regression. We have already discussed linear regression, how it works, the math behind linear regression. Everything is already discussed. If you have not watched these videos, please check out link in the description and also on the I button above. Just to do a quick recap, linear regression is all about drawing a line. If you remember the housing price prediction that we did, we plotted the data something like this, and we had price on the y-axis and size of the house on the x-axis, right? So when do we use linear regression is basically when we want to find out the continuous values, next continuous values. If size of the house is given, what will be the price of the house? In short, we are interested in the continuous value I mean. And hence, to find out the next continuous value when the size of the house is given, what will be the price of the house, that we can predict by drawing a best fitting line over the data. And how did we represented the line? How do we represent h? The hypothesis that we are calling is by this equation, h of x is equal to mx plus c. We already studied this in our schoolings. This can be represented also in this way, h of x is equal to theta 0 plus theta 1 x. It is just a different representation. In short, to draw a line, we need this equation. This is the equation for the line, right? And what we tried here, we tried to best fit the line over the data. That is important, right? Because we wanted to find the continuous value. And what is theta 0, theta 1 here? Just to understand, theta 0 is y-intercept. Where does this line intercepts on the y-axis? And theta 1 is the slope, is the angle, and x is the coefficient, is the input. This is what we have already seen in the previous videos. But now, in case of logistic regression is a classification technique. And when I say classification, we want to classify and we don't want to find the continuous value. Let's see example to understand this. We have a cancer data here plotted on x and y, and data is plotted for tumor size versus age. So the red ones are the harmless tumors and the green ones are the harmful tumors. So you can see we don't want to find a number or a continuous value. We want to find the class. Which tumor is a harmful and which tumor is a harmless, right? It is just about the classes. So when it is about the classes, we go for logistic regression. And I can also see that by just drawing a line over the data, I can divide this data. Similarly, to give you some classification examples, email, spam, not spam, house size, big, medium, large, also temperature, high, low. These are the classification examples. We are not interested in the actual value, but we're interested in the classes. This is what you need to remember. And very important thing to understand in logistic regression is drawing a line. Again, drawing a line. In case of linear regression, we were drawing a line, and even in the logistic regression, we are drawing a line. But the difference here is the way we draw a line. If I go back, just observe this. We were drawing a line to best fit over the data. In case of linear regression, we were drawing a line to best fit over the data. In case of logistic regression, we are drawing a line to divide the data, and it is not to best fit over the data, okay? It is to divide the data. So that's the difference. In case of linear regression, we are drawing a line. In case of logistic regression also, we are drawing a line. But the way we are drawing a line is different. Linear regression, we are drawing a line to best fit over the data. Logistic regression, we are drawing a line to divide the data, not to best fit, but to divide the data. Amazing. Simple, isn't it? So thing to remember here is logistic regression is generally used in the linearly separable data set because data is divided by drawing a line. So whenever you get any problem statement, you need to ask the question to yourself, do you want to classify the data or do you want to find the value, continuous value? So in other words, can I say applying linear regression model to classification is not a great idea because we are interested in the classes and not the continuous value. We don't want to best fit the line, we want to divide the data. We want to draw a line to divide the data. And in other words, can I say classification needs output as 0 and 1s? When I say classes, it is yes, no, high, low. In mathematical terms, it is nothing but 0 or 1, right? Y is equal to 0 or y is equal to 1. It is that simple. So we just want the output as 0 or 1. So the question here is, I need to find out some function which gives me 0 or 1. When you provide some input, I need 0 or 1. So which function can provide the output as 0 or 1? And the function that we are going to use in logistic regression is called sigmoid. You don't need to really use it, but internally the logistic regression uses sigmoid function. I'll explain sigmoid function quickly. One thing that you need to remember is we need the output as 0 and 1s, right? So if you need answer 0 or 1, I mean output 0 and 1, then just observe the image. What are we doing here? This is a sigmoid function, and on x-axis we have 0 and 1, I mean range between 0 and 1, and in the middle 0.5, and on the y-axis numbers in positive and in negatives. Simple. So what is special about sigmoid function? You provide any number. So on y-axis put any number to the sigmoid function. Okay, so if I put 2, what is the output I'm gonna get? Something here. And on x-axis I'll get 0.8 probably. If I put 4, I may get closer to 1. If I put 6, I'll get 1. If I put negative numbers, let's say negative 4, I'll get 0. If I put negative 6, I'll get 0 again. If I put something closer to 0, negative 2, I will get some value closer to 0.2. So whatever input value you're gonna provide to this sigmoid function, the output you will always get is in between 0 and 1. Most of the time the answer you will get 0 or 1, and sometimes when the values are closer to 0, you'll get answers ranging between 0 and 1. You will only get indecisive output when the input is provided 0. So for 0, the answer is 0.5. Otherwise, for all other inputs, whichever you're gonna provide, the answer will be 1 or 0. Amazing, right? So what we need to do is we just need to put the values in the sigmoid function so that we get the output as 0 and 1. So how does the equation looks like? So z here is the input, and this is what we are providing. G of z is equal to 1 divided by 1 plus e raised to minus z. What is beauty of this equation? The beauty of this equation is whenever you put any number on z, and if you calculate this equation, you will get the answer always less than 1. The value between 0 and 1. So that is what we wanted. So this is the simple equation to get the value between 0 and 1. Isn't it easy to understand? Just to conclude, sigmoid function converts input into range 0 to 1. That's it. Nothing different. It converts your input 0 to 1. So again, back to the original question. How do we draw a line? We draw a line by using theta 0 plus theta 1x. This is the equation we already saw, right? But rather than now h, we are representing it with z. So input is theta 0 plus theta 1x. That is the line that we are going to provide, right? And we are trying to understand how it is different than linear regression. So in case of linear regression, equation is h of x is equal to theta 0 plus theta 1x. And in case of logistic regression, the equation remains same, but we just put it in the sigmoid function and we are representing it with g. So the equation becomes h of x is equal to g of theta 0 plus theta 1x. So same equation, but we are just putting it inside sigmoid function. G here is a sigmoid function, nothing different. And in return, this g, that is sigmoid function, gives us answer either 0 or 1, a range between 0 or 1. So can I represent it in this way? Something like this. So in short, we will always get the value of h of x between 0 and 1. How? By using this sigmoid function. This is the beauty of this equation. And that is all. This is how logistic regression works. Amazing, isn't it? So logistic regression may not be always about binary classification. That is dividing your data into two classes. Yes or no, high, low, small, medium, spam, not spam. It's not only about binary classification. So logistic regression can also be used for multiclass classification. What is multiclass classification? Multiclass classification meaning where the data need to be classified into 3 types. I mean, there are more than 2 classes. There are small, medium, large. if I take example of Iris dataset, we have three classes, right? Setosa, versicolor, virginica, three types. So logistic regression can also be used for multi-class classification. And how does this works? It is one versus all. So it classifies one versus all and it keeps doing it again and again. So first time red versus others, second time blue versus others, and third time green versus others. So this is how multi-class classification works in logistic regression. I hope you liked this short video on math behind logistic regression. I'm trying my best to put the things into the simple words, and if you still have confusion, let me know. I'll create a more in-depth video here. This was a basic overview on logistic regression and how does the math work behind logistic regression. Before I end, make sure to like, subscribe and share with your friends. That's it for now. Thank you. Bye bye.